Hey everybody, it's Tony from Adafruit, and it's time for part 2 of the Raspberry Pi Internet Things series. So this is the second part in a series that I started on how to do like an Internet of Things device with a Raspberry Pi. So, let's say you have some hardware with the Raspberry Pi and you want to control it from a web page, be able to read the state of sensors or control different things on the hardware with it. So in part 1 of this series, I looked at just a simple way to use Python and the Flask web framework to create a basic little web application that can control an LED and read the state of a digital input on the Raspberry Pi. And so in this series, or in this video, we're going to go a little bit further and see how we can kind of polish it up, make it look a little bit nicer, and then look at an interesting thing called HTML5 server sent events, which is a good way for the server to push data to the client, like the web page that you're rendering on a web browser, in real time. So it's an easy way to get like an instant update when the switch changes. So let's just kind of dive into it. We'll jump to the desktop view here and we'll kind of get going with it. So first also I'll mention, if you're watching this on YouTube later, I'll put links down in the description. So I have all the code online. It's just in a little GitHub repository that you can check out here. So there's part 1 and part 2 inside of the repository. And then I'll show you what we're going to build in this stream, kind of the end result. And just kind of get an idea of what I'm going for. So this is the web page now, and if you remember from the earlier stream, it was a lot more bare bones and basic. So I've switched over to use a really nice little framework called Bootstrap. It's like a CSS or a cascading style sheet framework. It's an easy way to make web pages that look a little nicer than kind of the standard web pages. Some people might say it's a little overused, like almost every site on the internet uses Bootstrap or something like it. But I like it because, I'm not a web developer. I don't do front-end development. So I just want something that's easy and works. And I've kind of learned over time, Bootstrap, it's not perfect. Like it has some quirks. It's a little bit weird in some ways. But it gives you good results that look way better than just stock HTML. So you can see, nice titles and things like that. I've done no design work to this at all. Like I'm just using the stock components. But you can see the functionality is the same. So up in the corner up here, this is the Raspberry Pi. This is the Pi Model 3, but any model could work for this. And you can see now it's telling me here's the switch state, and the switch is just a little wire that I have here, and I'm moving it between 3.3 volts and ground, so it kind of goes on and off. But the cool thing is now if I move this over to ground, notice that the switch on the web page just changed, and if I move it back, so I'm not reloading the web page at all. It's just instantly updating here. And then the LED button, I can press this and you can see the LED turns on. I can press this, turns off, just like we saw in the first version of this. But the cool thing is kind of what's going on here with the switch here. So this is, behind the scenes, the web browser, there's actually a connection open to the server on the Raspberry Pi, and it's pushing every second the state of that switch. So it's saying, right now it's on, it's on, it's on. And then if I move it over, it's going to say, oh, it's off now. And then the web page updates instantly for it. So good example of the server pushing data to the web page here. And so we'll kind of dive in and see how I did this. So yeah, just to demo this again, I'll move that over so it's off. So let's just get started then. I'll connect to the Raspberry Pi, and I have this example running, but I'm going to stop it right now. I'm going to Control-C out of it. And then I'm also going to close the web page because there's a little quirk I'll explain later with the Bootstrap framework where the debug server can kind of be left running sometimes when you're using these server sent events. So I'm connected to the Pi, and let's go back up to a directory where I have, let's do part 2. So I've basically just copied over the part 1 code, and so I'm just starting with all of the code from part 1, and so we'll start from scratch there. And then I've got the text editor here, the Atom editor, and this is connected to the Raspberry Pi. I'm just using this neat little program called Mac Fusion that lets you connect to an SSH server like the Raspberry Pi and then edit it locally, the files on there on your file system. So okay, so this part 2 directory is where we're going to do all of our work. And so I've copied part 1. So, and actually, I'll just run it real fast as a little kind of recap of what we did in part 1, so you can see how this differs from what I just showed. So we'll run the web server, and now if I connect to the Raspberry Pi, you can see, okay, here's the old version. It's not dynamic. It tells me the switch state, but if I change that switch state, I don't see that update. I actually have to refresh the page to see it change. But LED still works. Nothing really changed with that. So, we'll kind of start from here. So the first thing I wanted to start with was looking at the Bootstrap library. So I'll show you how to integrate that library and see that, it's an easy way to kind of get started to make things that don't look super bad, basically. As I was looking around for the longest time, whenever I would make something like a project and I'd have to do a web page for it, the web page would look like this, just like basic titles. Because when I learned HTML in probably like 97, 98 or so, I remember it was when Netscape 2.0 came out. That was when I first kind of learned, okay, here's how to do HTML. Make web pages, and a lot of things have changed since then. So, I haven't really evolved much since then, but I've picked up a few tricks. So, okay, so Bootstrap, you go to getbootstrap.com. Real nice framework. I think some folks that worked at Twitter, and I'm not sure if they're still there anymore, created this. It's open source, really easy way to make nice web pages. It's a little bit complex and there's a little bit of a learning curve to it, but the web page is nice. There's lots of documentation and examples and things. It's really easy to kind of get going with it. So to get started, we need to download it and load it on the Pi, because basically it's distributed as some CSS files, some JavaScript files that we need to get on here. So we'll get this to the Pi, and what we're going to do is we'll download it. So let's see, we'll copy this link. And let's see, we'll stop our server real quick, and let's just download it to the directory we're in right now. So we'll just wget this, and we'll paste in the zip file. So okay, it downloads it. Now let's unzip it, and let's see. Okay, yeah, so this created a little Bootstrap directory in here, and then if we go into that Bootstrap directory, we can see it has basically a few other directories. So there's a CSS, a fonts, and a JS directory here. Now the way to integrate Bootstrap into our web page, so if you remember from part 1, there's the templates folder, and we have our index.html in here. And so this is the template that renders when you go to the Raspberry Pi, the web page, the main entry point. Because if you remember in the script that I created, the Flask application has this default route, and this renders that index.html template. So what I need to do in here to get started with Bootstrap is I need to include the CSS file that they include with Bootstrap, and then I also need to include a little JavaScript file that they include here too. And the way that I need to do it, so this is kind of static data, like it's not a template. So these are CSS files. They just need to live somewhere on the Pi and be served up by the server on here. But there's no magic that Flask needs to do to these things. Like it doesn't need to insert button state and stuff like that in there. So Flask actually has a concept of static data, and if you go to their web page, it's actually in the quick start. They talk about static files here. So real simple, easy kind of convention. You create a static folder right next to your template folder. You can put anything inside of there, and then you can use this URL for static kind of syntax here, and I'll show you in a second how to use this to get a link to your static data inside of a template. You could kind of hard code these paths, but this URL function, I'll talk more about this and why this is interesting. It lets you write in your template a reference to something without always having to reference the full path to it. Like Flask can kind of know that, oh, you're referencing a static file and I know where those things live. Or, maybe you're referencing some kind of a new path that we've created in the application. So, okay, so let's create a new folder. We'll call this static. And then inside of this folder, I actually need to copy in all the Bootstrap, the CSS, the fonts, the JS folder that they created. And you can see inside of here, like here's the Bootstrap source. The minified CSS files is like unreadable thing, but that's just because it's made to be really small. Luckily they include kind of, the normal ones. But like Bootstrap itself is really complex. Like it's built from a higher level abstraction above CSS. I think they use SAS or less, or one of these kind of languages that lets you write more flexible cascading style sheets. And then it gets compiled down into CSS, so it's not super easy to read it, but there's good docs on their page that tell you kind of how to customize it. So let's copy all three of these folders and move them over to our static folder here. So let's paste these in. Oops, let's see, where is the paste? There it is. So now I've got all those folders there. And now in my index.html, in my template, so I'll show you how we add a link to this. And from the Bootstrap page, you can kind of also see, talks about, getting started. It actually mentions right here, you can use a CDN. So in our web page, we could just put this CSS link directly inside of it, and it's actually going to reference Bootstrap off of this Max CDN. So basically a company has kind of donated their time and bandwidth to host the Bootstrap files on servers that are like basically built to handle high load like this, to send out these files. Now normally you want to do that, like that's generally a best practice, because those servers are going to be a lot faster than your servers and a lot faster than the Raspberry Pi. But I want this Pi to be standalone in the sense that, like, if you don't have internet connectivity and you connect to the Raspberry Pi, and actually if you go back to the Monday stream I did on using NetConnect-D, which is a really neat little daemon to set up a wireless network automatically, you can imagine if you had your Raspberry Pi, if it created its own wireless network and then you connected to it from your computer or a tablet, and maybe you didn't have internet access. As long as you can access the Pi, I still want to be able to render this page. So that's why I'm putting Bootstrap actually on the Pi itself and in that kind of static location. So I'm just going to copy out this link here just to get the syntax, and then I'll show you what we want to do to change this. So we put the link to the style sheet in here, and then the URL for this will be a lot different, and we don't need this cross-origin thing in here either because it's all going to be served from the Raspberry Pi. So so we need to give the URL for this. Now this is in that static folder, so we'll use a special syntax in the Bootstrap, or in the Flask template here. So at first I need to do the double curly braces to say, okay, this href value is actually some code in the template that I'm going to give, and I'm going to use that URL for function and then static, and then I actually give the path relative to this static folder. So I want to reference the CSS bootstrap min.css file. So I basically want to say, okay, so I want to go css/bootstrap.min.css file. And that's all I need to do here. So this is, Flask will internally see, oh, okay, you're calling the URL for, and it sees this static thing. It's a special value that says, okay, now construct a URL to the static folder here, and then reference some extra file inside of there that I've said. So Bootstrap will make a URL to this file in here, basically, from this. And the reason I do this is because, it makes sense. I might have lots of different static files. This URL function, we'll see, you can use it for more than just static stuff. So it's good to be in the habit of using URL for whenever you're trying to reference something that Flask knows about and kind of controls here. So I've got a reference to the style sheet. There's one other little thing. You generally in Bootstrap have to include a little JavaScript file that does some of the logic for Bootstrap. So we'll grab this little script tag and we'll insert it in, and we'll just like we did before, we'll make this reference the static file. So I'll put it above kind of my script. So like these first two lines, these load up jQuery like we looked at in the first video. So right after that we'll load up Bootstrap. So let's see, we'll kill kind of this part of it, and we'll just reference again with the URL for static. And now I want to go into the JS directory because I want to get the JavaScript and the bootstrap min.js. So let's do bootstrap.min.js. So so that's the static files, and let's just save this and let's run the server and let's actually just see what happens in here. So let's do Python main.py, and so if you remember, this is what the server looked like before. So we hit enter and something went wrong. It takes exactly one argument, 2 given. Okay, so I got the syntax wrong, but let's go back here. So I kind of got it wrong here. So I want to use actually file name equals. So I need to tell it here's the file name for this. So easy fix. So we'll go in here and say, yep, it's file name equals this, and file name equals this. So now let's save that, and let's refresh our page. And we should see, okay, so it changed a little bit. Like you can kind of see it went from like a serif font to a sans serif font. There's like no margin at all on the left here. The buttons look a little different. And that's because basically Bootstrap kind of sanitizes your browser's style sheets so that it makes everything kind of the most basic, minimalist, kind of simple state to get around a lot of browser quirks and things, because some browsers, you know, might pick a different font as kind of the default, and so this just says, okay, everything's going to use this sans serif font. Everything's going to kind of be, you know, set to like default margins and things. That's generally not how you want to use Bootstrap. Like you want to use Bootstrap kind of with the components that it includes. So like now that we've included it, you can actually go through and see they have really great documentation that tells you exactly what Bootstrap does. So one big thing is it has a concept of a grid where you can use this to align different objects and kind of move them around. So way back in the old days, you know, people would use a table to reference and like create different layouts of things. And then that kind of turned into something that was frowned upon, because you know you're creating a table just to lay things out, but a table means I've got tabular data, you know, columns and rows of things, and so you know, it kind of turned into more, well, how do we use style sheets? You know, use the things that are meant to control the rendering to control the layout of things. And so Bootstrap introduces this whole table system that we'll play a little bit with, but really nice and flexible. So this kind of shows you, like, you know, you can create rows of things, you can have different columns of things inside of here, so you can place things inside of different columns. You can have wide columns and short columns and kind of mix and match them. So real nice kind of system that Bootstrap has created here. But just including it by default also will do things like, you know, they'll make buttons that look a little bit nicer and softer and rounder. You know, they can be colored and do all kinds of cool things. So, you know, if you want to use Bootstrap, definitely go to the web page, go through all of their examples, you know, see what they've got here. But one thing that they do also is they have a few kind of example templates. Let's see, I think if we go back to getting started in here, and let's see, yeah, the basic templates that they have. So they kind of show some examples here. I like this Jumbotron example as kind of a simple starting point. So the Jumbotron in Bootstrap is kind of this component here, this big, you know, hey, here's a big title, it's kind of introducing something. And then below here is an example of the grid system. So these are actually 3 different columns or parts of the grid. And so, you know, these 3 items can have anything in here. So let's use this as kind of a starting point, and the easiest way to start using Bootstrap is to look at the code that they have. So if I view source for this example, you can see, like in the source, it's just including all the normal stuff. Like here, it's including Bootstrap. Their examples are a little fancier; they do some extra stuff. But then down in the body here, you can see like there's this nav bar. So this is actually defining the black kind of nav bar at the top of the screen here. And then right below that, there's the Jumbotron here. So this says, okay, here's where this hello world kind of title is, you know, so this part right here. So let's just start, let's dive in and start kind of making a little bit fancier version of our page. So in our index, so I've included Bootstrap, you know, it looks like it's working, so that's all good. So now let's just change how we render this stuff. So let's put in the Jumbotron class here. Let's see, we'll fix the tabs. So, okay, so we've got a Jumbotron. Now I won't get too far into the details of how to use Bootstrap, but generally it's based on, you create a lot of div elements, which are kind of components, and say, hey, this is some component. It doesn't really render as anything until you insert something inside of it. And then you assign a class to it. So this Jumbotron, you create a div of class Jumbotron and then a container inside of it. And then inside of this, we can put anything. So in the H1 header, you know, let's put our Raspberry Pi Internet of Things kind of title here. Let's copy this out, and we'll say this is part 2. Our description, maybe we'll copy this out and use the same description up here. So we'll just replace this paragraph. And then they have a little button, but I'm just going to delete this, so we don't really need that. So okay, cool. So I've gotten kind of these components. So let's just save this, and let's maybe see how the web page looks now. So if I hit this, so okay, that's cool. It's looking a little better. So you can see the Jumbotron gives a nice kind of header at the top of the page, real big headline to put information. So okay, so now I was thinking, let's put the switch in kind of one column and the LED buttons in another column here. So if we go back to the source for our example here, so I can imagine like I want to put the switch in one of these columns, and in the next column maybe the LED buttons and state for this. So you can see how they do this. So they create a container, and then they create a row, and then inside of that row there are these column classes, and you can see there are 3 column classes, and each one just represents or maps directly to the 3 columns that we see inside of here. So that's basically what I want to replicate in my code. So I'm just going to copy this out, and let's see, yeah, let's just copy this whole thing as is, and let's drop it in to our code here. So we'll make some room, and let's see, we'll fix up the tabs a little bit here. So we'll pull those in, and then I need to put a closing div in here. Let's see, so that closes the row, and then I need to close the container up here. So okay, so I've got the container, I've got a row, and you can have multiple rows. Like if I wanted to have lots of rows of items, you can create another div class row right below this. So now, okay, now I've got div class call MD4. So this is where it gets a little weird with Bootstrap. This is the grid system that they define, and so if we go back to the documentation at the top here, if we go to the CSS page, it has a little part on the grid system. So the way it kind of works is there are different classes for like the minimum width that a grid entry should be, and so the grid itself is subdivided into 12 equally sized components. So you can see like this top row is 12 units, and each grid item can be multiple units wide. So like for example, this one right here is 8 units wide, and it's right next to one that's 4 units wide. So in total that's 12 units wide, so that's going to fill the whole screen. But this is just 2 components effectively. So you kind of have flexibility here to control this. So for example, the little template we started with has 3 columns that are all 4 units wide, so that adds up to 12. So it's a full row of data, and you don't have to have a full row of that adds up to 12, but it kind of makes sense to keep things all consistent. Now this MD is like the size, which is the minimum size that this row should be, and I'll show you what this means. So Bootstrap is responsive in the sense that it's made to be viewed on small screens, big screens, any size screen. It tries to adapt itself to that. So like if you're looking at it on a phone, it tries to give you a nice view that you can render, whereas if you're looking at it on like a big retina display here, then that tries to also render something. And so as a part of that is kind of saying, okay, here's kind of how big this row should be and how large I want this to be at least. And they go into more detail here that in Bootstrap that kind of talks about this MD kind of means a medium-sized column. So this thing at minimum should be a medium size, which means it should render on like a normal kind of web page, on like a tablet or a computer, something that's longer than I think like maybe 1,000 pixels or something like that. So like what happens is, if I shrink the size of my browser page at some point, so you see what happened here, all of these rows just switch to filling the entire screen here. So we went from like one row of 12 things, if I kind of pull out, so like here's one row of 12 things, but when I make the screen just a little too small, Bootstrap realizes like, okay, there's not enough space to really render all 12 of these in a single row, so I'm just going to collapse them all down, and it just renders them kind of filling the entire screen one after another. And so the idea, the thinking for this is like, well, if you're looking on your phone and your phone's in a portrait orientation, it's not going to fit all the 12 of those things very easily. So it just says, well, it's better to render these all as a row that you can scroll up and down through, or as a column you can scroll up and down through. So that's kind of the meaning there of that medium size. It just controls when Bootstrap falls back to rendering in that kind of one after another mode for this. And so there are different sizes. So you can say, I can say column SM, I think for small, which says, okay, I'll let this shrink down to an even smaller size before you fall back to that kind of tiny little stacked on top of each other rendering mode. So it's just something to be aware of. It's a tricky thing as I started to learn Bootstrap, is just kind of understanding like why is this not rendering the right way? And it didn't really connect until I used it for a while. So I'm just going to keep this the same, the column MD4, but you can be aware of, you can change this to different things. There's small, large, extra large. I think they show in here somewhere. They have to, the different sizes that you can use here. So yeah, like it shows right here. So the column medium means that as long as your web page, the width of it is 970 pixels, then all of those column medium rows are going to render their normal size. But as soon as you shrink that web page down below 970 pixels, then boom, they start stacking on top of each other like that. So that's kind of the meaning for that. So okay, so we'll keep these the defaults, and let's start plugging in the information that we have. So let's put like our switch inside of one of these. So let's just pull this out, and we'll put it in here, and yeah, sure, we'll keep that at an H2 header. Now I don't need anything else in here. I'm going to delete these paragraphs that they have. And then let's put our buttons next to this. So we'll put a header on here. We'll say the LED, and then right after this, maybe let's delete this and put in a closing paragraph. And then let's just grab our buttons. So okay, we'll just grab those, drop those in. Okay, so now I've pretty much replaced everything in our web page, and now let's reload and see what it looks like. So okay, oh, I've got the third column in here, so let's delete this. So yeah, I want to pull this one out. So okay, so now I've got two columns, and you can see it's starting to look pretty nice. Like things are rendering well. I can still use it. I can press on, turns on the LED, everything is working as normal. But looks cleaner, looks professional, looks like I know what I'm doing, even though I'm just basically taking Bootstrap stuff and just jamming it in here, making it work. Now the buttons don't really look that nice, and I'll show you Bootstrap has a special way to deal with buttons. So if we go down to the buttons here, one nice thing too, the documentation for Bootstrap is excellent. Like everything has an example, it tells you exactly how to use it. They've really done a great job here. So okay, so the basic idea, you need to do a little bit of extra stuff with Bootstrap. You need to give it a special class when you use a button. So you need to use this btn button class, and then you can also give it an extra class that says how to render the button. So like their examples here, the default button is kind of clear, a primary one is blue, all kinds of different colors here. So it's neat that you get all this for free. You just add Bootstrap, and suddenly you can use these just by adding a different class name, like button warning if you want to get an orange button like this. So you don't have to go in and like edit your HTML and add like a color and figure out what's the hex code for that color. It's nice that Bootstrap has done some of that for you. But also, like, these are the stock Bootstrap settings. If you're making your own web page, you probably want to give it some personality, and there are ways to customize Bootstrap. You can go in and change all the colors and things, but I won't get into that. So okay, so for my button, I need to add that class. So let's add the button default to both of these. So we'll just save that, and then just by adding that class, we should see that okay, now the buttons change a little bit. They look a little nicer, kind of smoother. They still work just as before, so LED goes on and off. So okay, so that's looking kind of cool. At least the web page looks a little bit nicer. So okay, so I think we'll consider that a success with Bootstrap. So now let's kind of move on and see how we can go in and make this switch dynamic, so that right now it only changes when I refresh the page. So if I move this over, now if I refresh the page, now it's on. So I want to see a way to kind of push the state of this button to the web page, so that as soon as it changes, the web page instantly updates. And there's a neat technology we can use for this. So let's see, I'll close out the Bootstrap stuff. There's something called server sent events, and I'll put some links down to the pages that I'm talking about here. But it's part of HTML5, the spec for that introduced a way for the server to push data in real time to the client, the web page. And before this, there was actually a way that people would kind of emulate this. It was called long polling, where normally when you access a web page, your computer connects to the web page over like port 80 if it's not encrypted, or port 443, does a GET request. It says, okay, hey, give me this web page. And the server responds back and says, yep, here's the web page, sends it all back, and then you can close the connection, you're done. Like there's nothing else you get from the server. With long polling, it basically said, okay, I'm going to get some data, but server, hey, don't close your connection. Keep it open. Let's keep this connection open. And then when the server has new data, it can actually like send that data down that open connection and say, hey, you've got some extra state. You know, here's something that's changed. So they kind of formalized that in HTML5 with this concept of a server sent event. This page is great. It gives you a good explanation of it, kind of where it came from. But the basic idea is that in your JavaScript code, you can create this event source object, and you just point it at something like an endpoint on your web server, and then it talks this special server sent event protocol where it will keep a connection open to the server. And there's a real simple little framing protocol they have for it. So it talks about the format for the data. So basically, it has a certain MIME type, this text event stream MIME type. And then every time you want to send data to your server, you just write a line to that output connection that starts with data : and then whatever you want to send, and then 2 new line characters there. So like this example, they show like here's 2 lines of data that were sent. And then in the JavaScript code, this event source can actually have listeners connected to it that say, okay, when new data arrives, like this message function, run some of my code, do something like maybe change the state of my web page here. So it's, the basic idea is like you just tell JavaScript, I've got a special server send event source, here's the URL for it. Then your browser will actually know how to talk the server send event format. It'll open up that connection. Your server has to know how to keep the connection alive and talk the server sent protocol event format. So we'll basically do that. So I'm thinking, let's create a new endpoint on our application here that gives you the switch state as a server sent event format, so that it'll create a connection, and then every time the switch changes, or actually even just like once a second, I was thinking, we'll have it push down the state of the switch. And another web page too that I'll put a link to is, I also like this MDN, the Mozilla Developer Network. Really great resource for anything JavaScript, because I don't know a ton of JavaScript. I learn enough to do basic stuff like this, and so I'm always looking stuff up. MDN's webpage is the good one to go to. Usually when you Google search for stuff, you'll see like w3schools.org, and it's not a bad webpage, but I think MDN is better. Like, it's easier to read. It goes right to the point of like, here's what you want to look at. So they've got a great little page that talks about here's how to use server sent events, shows you the format from your JavaScript web page, and then from the server side from the page here. So we'll use this to get started. Now the big kind of question is, okay, in our Flask application, how do we use server sent events? Because right now we define functions and they have a route, but it's not a server sent event. Like the server is going to close the connection as soon as someone accesses this / route. We're going to basically just render the index template and send it back, and then close the connection. We're done. So there's a special way to do that, and actually Flask has a nice bit of documentation here about how to stream data, where you keep the connection alive and then you send data periodically. And that's exactly what we want to do with server sent events. And so they give an example here, like if you're sending a large file that maybe you have to read from disk or something like that, you can read it in chunks and send out chunks. And the basic idea is that you define a route like normal, a function with it, and then you return a response object and you pass it a generator function. And so a generator function is kind of a function in Python that you can call multiple times, and every time you call it, you might get back different data. Like, it's actually going to run a different part of your code. So like, they give an example, they actually define this generator function inside of this function, which Python's kind of cool. You can define functions inside functions, you can return them, it's really dynamic like that. But this function, it's a generator function because of this yield keyword. And I won't get too deep into this, but basically yield is kind of like a return function. If you write a function and you say return foo, then your function runs and it gets that return statement, and then it returns the value foo back. But the yield kind of says, okay, return this value, but I'm not done. So next time you call this function, start back not at the top of the function, but where yield was last called. So, you could imagine, like, if a function did 3 different things, maybe you could have 3 different yield statements, and so each time you called it, it would go through and, you'd get the first yield result, the next yield result, the next time you called it. So it's, basically a way for a function to kind of generate multiple results. And you use this in a lot of different places, but this is a great case for streaming data because I don't know when this data ends. There's no end to the switch state. Like I just want every second to send a new switch state. And so, basically this generator function they show here is just looping through, iterating through some object and then yielding the results every time. But this could just be like a loop that never ends, like, while true, just infinite loop. Grab the switch state, return the value, maybe wait a second, and then, when it runs again, it's going to go to the top of the loop and get the switch statement or get the current switch state, return it back and go from there. So let's kind of start, let's add like a server sent event endpoint, and we'll kind of slowly integrate it into our application here. So we need to create a new route for this. So let's make a route, and let's call this /switch, and then let's make a function for this. And it's not going to take any parameters. Basically, if you access this /switch endpoint, it's just going to start spitting back the value of the switch. Now to start with, I'm not actually going to use the switch. Let's just put in some random numbers. So I'm going to import a couple things at the top. Let's import the time library, and let's import random because I'm going to need both of these. And then in our switch function, let's make it exactly like the Flask example shows here. So we'll define a generator function, and then we'll return it using this response function. So this generate function, let's call this get switch values. And inside of here, so I don't need to loop through something. There's no definitive end to this data, so I'm going to do an infinite loop. So like while true, and now I want to say, okay, let's just yield a random number inside of here. So let's yield like random.randrange, random number between 0 and 100, and then let's sleep for a second. So let's do time.sleep 1.0. So that'll basically just pause for a second. So this thing's going to run forever, and just every second it's going to yield, like return a new random number back. And then now in this function, I need to return my get switch values function, and so that's going to start calling this generator function up above here. And then the MIME type, I'm actually going to change this. So server sent events have a different format. So like from this example page, they kind of show you, okay, you need to use the text event stream format. So let's copy this out, and let's change the MIME type here. So we'll use this. And now there's one other little thing, but maybe we'll try this as is. So it's not integrated into our web page, but I can still access it from the browser. So let's see. Oh, looks like I misspelled things. So this is interesting. The server was running in the background, and it reloaded, but it looks like it failed because I misspelled route. So we'll fix that. Now let's run the server, and so it's running. So okay, so our web page, it's going to be the same. Like nothing's different here. But if I go to the /switch endpoint, let's see what happens here. So it looked like something might have crashed. Is instance application must write bytes. Oh, interesting. So looks like I got something wrong here. So okay, let's kill the server and let's see what I got wrong. Let's go back to the web page. So okay, so the switch function, it's an app.route, and let's see, I'm calling get switch values, and oh, okay, interesting. So it must be because I'm yielding just a raw number. So let's just say, my value is this. So actually, I want to yield text instead of a number. I have a feeling that's what was throwing it off. So let's save this, and now let's try this kind of example. And let's go back to that switch endpoint. So we go /switch. Okay, so now we see, okay, so check this out. Like notice that this page, we're seeing new data come back. Like we're seeing value, 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 and it doesn't have a new line, unfortunately, so we're just kind of seeing some weird results here. But this is kind of cool. So it's showing us that every second, basically this while loop is running. It's generating a new random value. It's returning it. Flask is returning that back to my web page here, and then it waits a second and just repeats it over and over and does it again. So okay, so this is pretty cool. Now the format of the data that I'm sending, it's not in the right format. So I actually, if you look at the server sent event format, you need to have this data : and then new line, new line. So let's just change our data here to match that format. So let's do data : and then let's put in new line here, and let's save this. So that's going to reload the page. Now let's see if I reload this. Now we see, okay, we're starting to get data back, so it's coming back in the server sent event format. So okay, so let's integrate this into our web page now and see kind of how to make this thing work on our page here. So let's see, yeah, I went back to the page there. So let's jump to our index template, and now I need to put a little more JavaScript in here. So right now I have a script, and to start with, it basically just attaches button click handlers. And now we want to set up the switch server sent event endpoint. And I'll go to the MDN page because it's nice and simple, and we'll just copy this out. So we need to create an event source in our page. So let's do that. And let's call this switch source. And then I need to point it at a URL. So this is what the browser is going to call to start getting this server sent event data, and that's the /switch endpoint that I created. Now I could hard code this in and put /switch, but the thing is, what if I change the name of this endpoint? It's a little brittle in the sense that I have to go back and change this template. So let's use that little URL for function in Flask, and you can actually just give it the name of one of your functions that's a route. So I can say, I want to do the URL for this switch function, and Flask will then generate a URL that uses this /switch route. But if I change this to like maybe switch state or something like that, Flask is smart, and it's going to know that URL function is going to return the new value of this. So I don't have to go back and change the template. So it's a nice little thing that you can do anytime you want to reference one of your routes. Use this URL function. So we'll do the URL for the switch. And okay, so that'll create the event source. Now there's one other little thing I need to do. So I need to actually attach an onMessage handler to this that says, okay, when you receive new data from the server, do something. You can just like log it, you can update the web page. So let's just copy in the code that they have here and move it over there so it's a little nicer. So okay, so we need to change this to switch source because I changed the name of the object. And okay, so we're gonna set onMessage to a function. Now in their example here, they go and actually change the web page. Let's just do a console.log. So we'll do console.log and e.data. So this function gets passed parameter e, and so that's kind of the state of the message callback, and it has a data value that actually has the data that our server sent back. So let's save this. And let's go back to our web page now, and let's run this, and let's see. Okay, so that loaded, and now let's open up the console. So if I view the JavaScript console on here, so okay, this is cool. So now we're seeing all of these console log messages, and you can kind of see like every second we're getting a new random value in here. And yeah, I can move that over a little bit. So that's kind of, you can see the responsiveness of Bootstrap in action, just resizing things. They kind of move. Switch down. So okay, cool. So we're pretty close. We're getting random data now. So let's actually set the value of switch to the data that's coming back here. So let's go in, and in here now I actually need to change things a little bit. So up here is where I have switch. I need a way to insert a value inside of here. So the span tag in HTML is usually what you want to use here. So this is kind of like a placeholder that says, okay, put something inside of here. Like I can start it out with the value of the switch when the page loads, but I can also give this an ID. So I can say, let's call this switch value, and so now I can reference this span later. And so now in my code, so instead of logging it, let's actually use jQuery, and we'll say, okay, find that switch value object, and then set its text to e.data, which is basically the value we received from the server. So now let's reload the page and see what happens here. So I'll hit enter, and okay, so you might see something's not really working here. Like the page didn't reload. We're spinning. We're seeing results here, but we're not actually getting our page to render. And you might like wonder, okay, what's wrong? Like the server's not working. Looks like it's working. Everything seems okay. Now the big problem is, so in our Flask application, this while loop here is an infinite loop. Like this thing never ends. And by default, the Flask web server doesn't have any threads or like ways to run multiple things at once. So that, once a web page asks for this switch route, my Flask server is going to go into this infinite loop and it's never going to return. And that's actually what's happening here because, I'm trying to refresh the web page. I'm trying to access that / route, but my server is stuck handling this message loop here. And so, like what do we do? So this is kind of a case where, if you haven't done a lot of server programming or server-side kind of back-end programming, you really have to think about multiprocessing and multi-threading, like doing multiple things at once, because this web page, even though it's like one file of code, multiple things could be hitting this web page at once. You could have hundreds of users, or like imagine like Facebook.com, they get millions of users a second, I'm sure, accessing their page. And so, your servers have to be able to handle that kind of load and talk to multiple things, have multiple connections open. So by default, the Flask debug server is pretty simple. It doesn't do threading, but luckily we can turn on threading. So if we just do this threading equals true in our app.run, and I save this, then actually we'll see. So the server, it's going to fail. It's not threading. Maybe it's threaded. Threaded equals true. So let's save that, and now let's start our server up. And so, okay, now it doesn't really tell us, like nothing looks different here, but behind the scenes, now our Flask server is multi-threaded so that every time a request comes in, a new thread is created. And a thread, if you're not familiar, is like it's a way for multiple things to run. Basically, the kernel on the Raspberry Pi can have a program, and a program can create a thread, and a thread can just be code. It can be anything. It might be reading button state, it might be rendering a web page. And the Raspberry Pi kernel, the Linux kernel, is smart enough to say, okay, each thread gets a little bit of time to run, and it can switch between them all. Each thread is active for a little bit of time. It's an easy way for a program to do multiple things at once or at the same time. You create a thread, let it go run and do its own thing in the background. So we've told our server to do that. So now when something asks for this switch route, it's going to happen in its own thread. And that thread is free to do whatever it wants. It can bury itself into an infinite loop and just constantly spit back results. And if a new request comes in, like for this / route, a new thread will be created. And the Raspberry Pi kernel is smart enough to switch between these so that this new thread gets some time. It can render a page. The previous thread that is running this switch will get some time to run. So it's it's smart about letting each of those things happen at once. It feels like you're doing two things at once, even though a single CPU core on the Pi can really only do one thing at once in this case. So now our page, it should be rendering. So you can see it renders, we can reload it, and this is cool. Like you can see our switch value is changing now. Like every second we're getting a new random value back for this. So it looks like things are kind of working here. We're getting the server sent events. Now you might notice in the background here, like after I restarted the page, you get this kind of broken pipe error. And this is just a side effect of, right now the browser has this page open, and it has that server sent event connection open, and that has a thread tied up in the Flask web server. Now if I go away from this page, and maybe just go back to this default page, that thread now on the Flask server that's trying to send those server sent events suddenly sees, oh, your connection's closed, uh-oh. And that's what this error means, is that basically the web page closed the connection, and so it can't write data. The pipe is broken to this. You can ignore it. I'm sure there's probably a better way to handle this more gracefully, but it's not too crazy as far as for a simple application like this. You can just kind of keep going with the basics that it gives you. So okay, so we've got multiple threads. We've got the switch state coming back, or at least we've got a random value coming back. Let's get the switch state and return it back. So we'll use the same code for when we render the page. So we'll do the read switch. So we'll get the switch value, and now let's send the switch value down to the page instead of calling random. So We'll give it this value. Now switch, that get read switch function returns either a 0 or a 1 to tell you if the switch is on or off. So let's just see how it looks as is. You know, I just saved it. Now I should be able to access Raspberry Pi 5000. So now we see, okay, so here it's telling me switch equals 1. That means it's on. So now if I move this over to 0, there we go. Or I moved it over to ground, so now we see 0. So that's kind of cool. Like it's, you know, basically, oops, I moved to the wrong pin there. So now it's on for this. And if I want, I can actually go, you know, to that switch endpoint again, and you can see like there's no real magic to this. At least, oh, maybe I can go to this. Let's see. Let's go back to the web page here. Let's do Raspberry Pi /switch. I might not be able to access this thing because okay, yeah, there I can. I'm not sure if the browser can let you view a raw SSE server-side event format thing, but I can change this. And you can see, okay, now the data changes to 0. I move it back. Now the data changes to 1 in this case. So that's cool. Looks like, you know, everything's working. So we'll go back to our web page here. So okay, let's make this a little nicer though. So let's change this so that instead of rendering 0 and 1, it actually renders, you know, on or off, something like that. So what I was thinking, let's go into the index, our template here, and let's make a new function inside of here because there are 2 places I have this rendering logic. So, you know, right now when I receive a new server-sent event bit of data, like the new switch state, I'm setting it here in this onMessage function. And then also when the page loads, this little template runs and it gets the current value of the switch that was passed into it. So, you know, that's from the first video I showed, you know, basic kind of sending in a value to the template here. So, you know, I could change my code. I could put some logic down in this onMessage function to say, okay, if you get a value of 0, set it to on. If you get a value of 1, set it to off. But I'd like to put that in one spot. So let's make a function that basically takes care of whenever I have a new switch value, set the value of the switch on the web page. So, you know, let's do function update switch, and it should take in new switch value. And so this function, let's define, or let's have it set the value of our switch. So, you know, we'll basically have it set the text, and we want to have it set to on or off. So, like, for example, let's do an on, and we want to change the behavior based on switch value. So if switch value equals 1, then it's on. So we'll call this code. And else if switch value equals 0, and I do the triple equals in JavaScript because basically JavaScript sometimes tries to coalesce values, like if it's an integer and you're trying to compare against a string, then it'll do that conversion automatically. Generally best practice to do triple equals because triple equals means, you know, don't do that coalescing. Like I really want to check, is this equal to the string 1 or the string 0 in this case, because all kinds of bugs in JavaScript come from that coalescing, and you know, if you only do a double equals, so generally you always want to do triple equals. So okay, so now if it's off, then let's change switch value to off. So okay, so that's cool. So now I can call my update switch function here, and I just pass in the eData, the template I received, or the data I received from the server-sent events. And now when the page loads, let's move from having it render the value directly here into calling our update switch function. So in our JavaScript, let's just put a call to update switch, and the value that I pass in, I'm going to use the value of the switch template that's passed in. So I don't need to do this conversion, you know, this formatting in here like I did before, where I said, okay, if it's 0, then render on or off. You know, basically this just means grab the value of switch and pass it to my update switch function as a string. And so the value of switch is going to be 0 or 1 because it's the value that we got when we called our getSwitch function on the PyThing object. So okay, so let's save this and let's reload our page, and we should see that, okay, that's cool. So now switch says on because, you know, the page loaded up, it got through our JavaScript, it called our update switch function, and that went in and said, okay, if it equals 1, then render it as on. So, and now that server-side event is fired up in the background. It's pushing data. And now if I change this, we should actually see this change off. So that's cool. Look, it just changed off. I go back and it goes to on. Oops, if I get it on the right row there. So it goes on. So that's cool. Now there's one little thing we can do. We can actually make this a little bit nicer. So one cool little thing that Bootstrap has, so if I go back to Bootstrap, you can actually give a label that's like a little bit nicer render, something that's kind of highlighted, that's a little more visual. So if I go down to the label objects here, so you can kind of see, like, you can create a label and Bootstrap will just render it in a more obvious way. Like, this one's kind of inverted, a little more contrast. You can give different colors to labels. So again, a label is just adding some extra classes, like label default, for example, for this. So for my object, so I could apply a label default class to this span. Oops, let's say, so label default. Now when I re-render this, it should be a little more visible. So you can see, yeah, it's a little bit easier to read. But I wanted to go a little further. Let's actually change this. So how about when it's on, it's a red label, like they kind of show here, like the danger label. And then when it's off, maybe we'll do the default label, the kind of normal, darker colored one here. And so we can do that. All we have to do is just change this class on this span. So, change it from label default to label danger if it's on or off. And so let's do that in the update switch function, because this function knows how to render the state of the switch. So if it's on, I want to change the state of its classes. And luckily jQuery has some nice little helper functions we can use. So let's do switch value, and I want to do toggle class. So this lets you add or remove a CSS class to an item. And so I want to remove, basically I want to say, okay, I want label default to be false. So this means remove label default if it's applied to it. And then I want to copy this, and we want to actually apply label danger and set this to true. And so this means, this first line will remove label default, and this next one will add label danger to this. There are other ways you can do this with jQuery, but this just seemed like the most straightforward. And then for the off case, I want to invert these and say, okay, now I want it to be label default and label danger off, so false. So okay, so let's save that and let's re-render our page. Oops. And we should see, okay, now it's red when it's on, so that's kind of cool. Let's change it. And now we see it goes off, so that's pretty cool. So just by moving that around, and you can see how quick it is. It's just every second it's sending the new state of that switch. So it's pretty fast to update this. And then again, the LED still works, so I can press on, press off, turn that on and off. So that's pretty cool. I mean, we're pretty much there. We've got the basic functionality. Now there's one extra thing I want to show here, and it's not really necessary right now, but it's a good best practice. So you saw how we turned this server into a multi-threaded server. We gave it the threaded equals true, and we had to do that because some of our functions here are just always returning data, and so a single threaded server wouldn't work because this while loop is just going to steal all of the processing of our function. So we've got multiple threads running now, but a big issue with multiple threads is you can have contention where if two threads are trying to access the same thing at the same time, they're going to fight over that, and they might like stomp all over each other. For example, like if I had some component that I had to send a couple messages to and then read some state back, if two requests came in at the same time that triggered that behavior, they're going to get jumbled up and fight each other. They might happen out of order. So it's a big issue with multi-threading that you need to be aware of. Is just thinking about, okay, what runs at the same time, what do those things do, and what needs to be atomic, which kind of means, what are things that have to happen all at once, like it's an all or none thing. Like reading the state of this switch, you can imagine, should be atomic. Like, I don't want it to like get halfway through reading the switch and then suddenly try to start reading the switch again. Now, luckily, in a lot of cases, some of this stuff, like I think reading digital I/O, is generally atomic. I'm not totally sure on that because some of this stuff is using the sysfs interface underneath the covers in Linux, and sometimes the way Python works, because this is a whole other can of worms, but even though Python is multi-threaded, multiple threads don't run at the same time in Python. And it's a big head scratcher, especially if you're coming from other languages. It's like, what? Like, okay, why is it even multi-threaded? And it's because Python has this concept of like this global interpreter lock. It's a big rat's nest of issues and things. But basically, Python is multi-threaded, but like that doesn't necessarily mean two things run at the same time. And there are ways to get around that. There are all kinds of interesting frameworks and things that really are multi-threaded or do multiple things at once, but they have to jump through a lot of hoops to get through that. And Python 3 actually has a whole async architecture that gets around this whole issue. But just something to be aware of, that sometimes in Python you can do multi-threaded things that work and don't use a lot of like locking or multi-threaded kind of conventions or ways to access data, and they'll work, but that's because they really aren't multi-threaded, or like multiple things aren't running at the same time. But okay, so generally when you're using multiple threads, if you want to synchronize them or make things atomic or ensure that like two threads don't run the same code at the same time, you can use something called a lock. And so in Python, they actually have a great threading library. The threading library, it's in the standard library, and it has this lock object, and it's super easy to use. So it's it's basically you create a lock, and then you can use a context manager like a with statement to put some code that's associated with that lock that basically says, okay, when this code runs, make sure no other thread is running this code right now. And if another thread is running this code, wait, like just sit there and do nothing until that thread is done, and then run my code, so that it serializes access to that block of code, so that that code is only run by one thread at a time. So you'll never have a case where half of your code runs and then another thread comes in and starts running your code from the top and messes up the state of everything. So a lock is a good way to serialize access. And so I think the best place to put this is inside of our thing object here, because we could put this into our Flask web server, but then we're kind of mixing a lot excuse me, we're mixing a lot of state here. The web server now has to know about multiple threads and things. Basically I should make my thing thread safe, in the sense that multiple threads can call its functions, and it should be smart and do that locking itself. So I'm just going to add the threading library here. So we'll import threading, and I need to create a lock object to use to kind of enable the lock. And so I'm going to create it inside of my initializer here, and I'll save this lock on this object. So for each Pi thing that's created, it has its own lock that it'll use to serialize access. And I'm only ever going to create one Pi thing, so it's not really necessary to put it in here, but it kind of makes sense. It's state that's associated with this Pi thing. So let's just say self.lock equals the threading.lock object. And I like, it's a Python convention to put an underscore in front of private members. Python doesn't enforce that this thing's private. Anything could access this lock member, but the underscore just kind of says, hey, you probably shouldn't be accessing this because it's a private variable here. So now that I have the lock, to put a block of code that, inside of that lock, basically to say, okay, take this lock before you run this code, you can use a context manager in Python, which is the with statement. So we can say with our self.lock, and then you indent that and give a new block of code. So this basically means, okay, when I want to run this block of code here, this call gpio.input, first acquire this lock that I created. And to acquire the lock, it basically means wait for any other thread that's running to finish, and then jump in and start running your code. So it serializes all the access here. That's basically, I could have other code in here, if I wanted to do other things, read other state. I could, like maybe reading the switch requires me, talking to some component. I could have the code inside of here that does that. And it's all atomic. It all happens at once because of this lock that I'm using here. So I'm just going to put the lock here. So this basically means, if two read switch calls come in at the same time, only one of them is going to run at once, and they're both going to know that whatever gpio.input is doing, it's going to happen in isolation from any other threads that are running at the same time. I'm going to do the lock also on my output, on setting the LED, and it's maybe not necessary, but I think it's good practice, because as this thing gets more advanced, basically this lock means that I'm accessing hardware. So this lock is effectively like anytime I want to talk to my hardware, because there's only one physical instance of this hardware. There's only one LED, there's only one switch. So I can never have a case where like two requests come in to set the LED at the same time, and each one should set different LEDs. They're both trying to talk to that same LED. So I want to serialize access to those using that lock. So this lock is effectively just saying, make sure that multiple threads don't access the same data at the same time. So okay, so let's save this. And one thing I can do, so I'm actually going to cancel the server, and let's use that little test program that I had, the thingtest.py, because I want to make sure that I didn't break anything in my my code here by adding that thread, and it looks like it's fine. So remember this little thing test, it just reads the switch and then blinks the LED forever, so that looks good. So let's run the server again, and let's see. Oh, interesting. So this is another little error that you sometimes might see with the Flask web server. If I have a web page open like this page and it's still connected to that server sent event endpoint, it actually, maybe it's a bug, maybe it's not a bug, but it keeps my Flask server running. So if I look at all my processes, if I look for all my Python processes, you can see here's Python running my main.py, and it's still running even though I canceled it earlier. And that's just because there's a thread that's still running that little server sent event loop. But as soon as I exit this web page, like if I go back, or here, even if I just close it like this, then you'll actually see that thread dies. So there was like some output here where it said, uh-oh, broken pipe, I don't know what to do. And now if I look and see, now that Python process isn't running anymore. So just something to be aware of. If you get that weird error, if you're doing multiple threads, the Flask debug server is really not a production server. So this little web server we're using here, real Python web servers, things like there's like GUnicorn, there are lots of WSGI servers. They're a lot better about threading and making sure, like some of them aren't even threaded at all. Some of them use like a more asynchronous IO internally, but they're smarter about handling connections. And when you have some web page that keeps a connection open, this server is not that smart. So in this case, you just have to close the old web page, or you could kill the process even if you wanted to. So okay, so now let's run our server again. So now it runs, and now I can access Raspberry Pi port 5000. There's our web page. Everything looks good. Let's change our switch, and we should see this update. So it goes off, and we move our switch back, and suddenly it's on. So that's cool. Change LED on, off. So that's pretty cool. I think that's what I wanted to show for this part 2. We took our real basic bare bones example, didn't look very pretty. We added the Bootstrap framework, and I wouldn't say that this is like beautiful, but it's certainly nicer looking than it was. And you can see like Bootstrap is super powerful. It gives you all of these awesome little components, things that you can just plug in without a ton of code and make a web page that looks a little more interesting than just a basic one. And then the big thing in this part 2 that we saw was how to use the server sent event format to send data from the server to the client web page in real time, so that as soon as it updates, you can see the web page update instantly like that. So real powerful thing that you can use. This is great for like sending sensor data to a web page and just pushing it constantly. So the next video I'll do next week, I'm thinking of going the next step, because okay, what happens when now on your web page you want to send data to the server in real time? And so there's a whole other technology for that called WebSockets that we'll play with and see. But that actually lets you do both ways, where the server pushes data and the client pushes data back. So you can do lots of powerful things with that, like instantly have the switch update in real time, which you kind of have that right now, but we're calling a little URL behind the scenes right here. We're calling the /LED URL that we defined here, this little LED endpoint. So I think that's it. If people have questions, maybe throw them into the chat right now. And let's see, we'll jump back to kind of the main shot here. So yeah, put any questions in here. Let's see. I don't see much questions here so far. But yeah, like I said, this is part 2. Go back to part 1 and you can kind of see the early start to this web app. And so part 3, like I said, we'll look at how we can do kind of two-way communication between the server and the client using a WebSocket connection. So let's see. I think that's it. So yeah, so subscribe to Adafruit's YouTube channel and you'll be able to see this video and other fun project videos. Subscribe to twitch.tv/Adafruit and you can watch live streams like this in real time and see all kinds of other fun stuff. There's the Desk of Lady Ada, or live streams that Lady Ada likes to do. Noah and Pedro have the 3D printing hangouts and live streams there too, so all kinds of fun stuff. So thanks a lot, everybody, and I'll see you Monday. I'll do another Pi stream. We'll do something kind of fun with that. Usually the Monday streams I like to maybe look at like software, maybe not do as much coding stuff. And then Friday next week we'll pick up and we'll do part 3 of the Pi Internet Thing video series. So thanks a lot for watching, everybody, and I'll see you guys later.